In the last session, we started 3.2 and we have studied product rule. So we have studied the product rule and we did some examples. And we did till example number 3 and got 6.5. We have done till example number 3. And now we have to move ourselves to the quotient rule. Is so far clear to you? I mean, do you have any question?
No, everything's clear.
Okay, so let's move on to the quotient rule. This rule, like a product rule, is very important. So you just need to memorize this formula. Let's try to understand this formula in the class. 1 minute, let me just write it down. Quotient rule. Quotient or divide rule. Okay, if we have, so far we have studied if two functions are multiplied, if two functions are added, if two functions are subtracted, what will be the formula? If the two functions are divided, for example, there is one function f of x, another function is g of x, and someone asked us to find its derivative. So the formula is we will keep g of x as it is, and we will be taking the derivative of f of x will be f dash of x, right?
Okay, yeah.
Then there will be a minus sign of the formula, and then we will keep f of x as it is, and we will differentiate g of x, which will be g dash of x, and then we will be squaring g of x. That's the formula.
So the top part is like the earlier one we did, right?
I didn't get you. Sorry, can you repeat it?
The one on the top part, g of x, and then f prime x. This is the same as we did last time, right? Like,
no,
we leave one and then we do the other, and then we leave one and we do the other.
Yeah, but there wasn't plus sign in between. But yeah, then their order doesn't matter if we do g of x and then f dash of x, or f of x and then g dash of. But here the two terms are subtracted, so the order does matter to us, that we have to first keep g of x as it is and then have to differentiate f dash of x, and then f of x as it is, have to differentiate g dash of x, and then we have to square g of x function. Is it clear? Okay, let's start with an example, a very simpler one. d of x of x square over ex. G of x is e of x, right?
Again?
This is our f of x.
Yeah, and then g of
This
x
is
the one at the bottom.
Yeah, so the g of x is e of x of the formula, and then we will differentiate f dash of x, I mean f of x. Our f of x is x square. If we differentiate it, it would be 2x.
2x, yes.
And then there's a minus sign of the formula, keeping f of x as it is, so x square. And then there is g dash of x. If we differentiate exponential function, what will be its derivative? E of x as it is, right?
Yeah.
And then there we have to square g of x. So g of x is ex. We have to take square. Now simplifying it, it will be 2x ex minus x square ex e raised to the power 2x. Is it clear?
Yes. Yes.
Okay. We can further even simplify it, we taking the ex common, and then it will be left 2x minus x square, but that's not necessary. We just need to learn, we are just here to learn the rules of the differentiation. Is it clear?
No, yes, clear.
Okay, let's back to the book and do the example from the book. Okay, let's do the example number 4, which is quite complicated. So our function is x squared plus x minus 2 divided by x3 plus 6. And using, we know that both the functions are dividing. So we have to use u over v or dividing formula of the differentiation. So let's write down the function first. X cubed plus 6. So this is an example from a book. So both the functions are dividing. So we have to use a formula, f of x and g of x, right?
Yeah.
So this is our g of x. Now, keeping g
I'm not
of
seeing
x.
the other screen. I'm seeing the
Sorry?
book. I'm still seeing the book.
Oh, wait. Just let me share it again. Can you see it now?
Yes.
Okay. So this is g of x and this is f of x. So using the formula, dividing formula, g of x is x3 plus 6, right? And then we have to differentiate f of x. So f of x will be
2x plus
yes
0
2x
minus
plus
1.
It is x squared plus x minus 2.
X minus 2. That's gonna be 1, right? X will be 1. And then the minus 2 will be cancelled.
Okay, then there's a minus sign of the formula and keeping x squared plus x minus 2 as it is.
Okay, now it's gonna be 3x squared. That's it. And then it's gonna be 3x squared, right?
Yes, 3x squared.
And then plus 6 will get cancelled.
Okay, so and we have 3x cubed plus 6 whole square.
So, yes.
Now we have to just simplify it. We have to multiply the two expressions. So x3 with 2x first, it will be 2x4. And then x3 with 1, it will be x cubed. 6 with whole expression, it will be 12x. And
Plus
6
6.
with 1, 6. Is it clear?
Yes.
Okay. And now multiplying x squared plus x minus 2 with 3x squared, it will be 3x4 plus 3x3 minus 6x squared divided by x cubed plus 6 divided a whole square 2. Two x4 minus plus x cubed plus 12x plus 6 minus 3x4 minus plus 9 or plus 3, sorry, plus 3x cubed minus plus 6x square over x cubed plus 6 whole square. Is it clear?
Yes.
Okay. And now just add and subtract the common terms, the like terms. So minus 3x4 plus 2x4 will be minus x4. And x cubed plus 3x cubed will be 4x cubed. And 12, and there isn't any term for x square, so 6x square plus 12x plus 6. And then we have x cubed plus 6 whole square. Is it clear?
Yes.
Okay, I don't think so. We need to simplify it further. So that's the answer. Let's back to the book.
How can we simplify anyway?
You mean further simplification?
Yeah.
Further simplification is not possible because if we simplify it further, there's no use of it. So yeah.
Okay.
Let's back to the book. So we have got the same answer, I think, minus x4. There was a plus sign. Like we multiplied plus x with minus 3x square. So it should be 3x cube, right? Plus 3x cube, not minus 3x cube. And then we are multiplying minus sign with the whole function. So it will be minus 3x cube. And minus 3x cube plus 3x. Sorry?
For which one is this?
The same question.
No, which part, I mean?
We multiplied minus sign with the whole expression. Then it will be minus plus, should be minus sign. I wrote here a plus sign in by mistake. So when we subtract minus 3x cube with plus 3x cube, it should be minus 2x cube. Is it clear?
Yes.
Rest of the part were correct. So let's back to the book. Should we do more example on that, this division?
Yeah, one more, because it's so long and there are so many steps. I just want to make sure I fully understand.
Okay. D over dx of x5 plus 4x. And in the bottom, we have 3x square plus 2x plus 1. Okay, this is the function. We have to take its differentiation. So this is our f of x. And this is our g of x. Again, g of x, 3x square plus 2x plus 1.
Yeah, and then the other one is, I mean, 5x to the power of 4 plus 1. No,
4x4 plus 4, right?
4x4.
Is it clear?
It's 5x4, not 4x4.
Okay, 1 minute. It should be 5x4. 5x4 plus 4, and then minus sign of the formula. And then we have x5 plus 4x as it is. And what will be the derivative of g of x? Hello. Your voice is cut.
Hello, now can you hear me?
No.
Hello now.
Yes, now it's audible.
Yes.
Okay, now tell me the derivative of g of x. It will be?
It will be 6x.
6x plus?
2.
Yes. And then we should have g of x whole square. So 3x square plus 2x plus 1 whole square, right? Again, we have to multiply the expressions. So it will be 5 times 3 is 15. And x times 4 and x times 2 will be x6 plus 12x square plus sign. Then we have 10 x5 plus sign 8x plus 5x4 plus 4. Is it clear?
Yes.
And now multiplying these two expressions, it will be 6x6, right? Plus sign 12x square plus 2x5 plus 8x. Is it clear? Hello, are you there? Okay, so when we simplified our fractions, this fraction with this, we got 6x6 plus 24x square plus 2x5 plus 8x. Is it clear?
Yes.
Okay, so we have 3x square plus 2x plus 1 in the denominator, the whole square. Now we just add and subtract the like terms. 15x6 and minus 6x6 will be 9x6. Right?
X6.
And then we have 12x square and plus 20. Let's move on to the x5 terms. It is minus 2x5 and 5x and 10x5. So 10x5
12.
and minus 2x5. It will be 8x5. And then x4 term, it is 5x4. And there isn't any term for 5x4. I'm in the x4 here. So it will be plus 5x4. And then move on to the x cube term. There isn't any x cube term. So let's skip it. Now let's move on to the x square term, which is 12x square here. And we have 24x square minus 24x square here. So it will be minus 12x square. Is it clear to you so far?
Yeah.
And then we have 8x and 8x minus 8x. So it will be cancel out. So we don't have any x term. And then let's move on to the constant term. Constant is plus 4. And we don't have any constant term here. So it will be plus 4 divided by 3x square plus 2x plus 1 whole square. This is the answer. Is it clear?
Yeah.
Okay.
This is the final answer, right?
Yes, this is the final. So further we can't simplify it. Even if we,
Okay.
find the square, simplify it, we can't further simplify. So there's no use to do it. So this is the answer. Should we do another question or is it clear to you? I mean, the easiest one that you should try it yourself.
Yeah, until now it's good. I understood.
Okay. Let's move on to the book. Okay, let's do the example number 5. That is find the equation of a tangent line to the curve. The curve is y equals to ex 1 plus x square at the point 1 comma 1/2 exponent. So let's write down the curve formula. That was y equals to ex1 plus x square and another information that is given to us at this point, which is 1 comma half e. Okay, what they have asked us to find the equation of a tangent line to the curve.
The question was find the equation to the tangent line.
Mm-hmm. And the graph that is given to us here in the figure 4 is a curve graph. It's shown to us here in the figure 4, and we have to find out the tangent line. We have to find the line that is tangent to the curve at the point 1 comma half e, and the equation of curve is given to us. So we have to find out that equation, the equation of a line that is tangent to the curve at that point that is given to us. Okay, we know that to find the equation of any line, we need a point and a slope, right? For the slope, we know that if we differentiate our function, the function that is given us here.
Hello.
Hello.
Yeah, I came back. So
Hello. Hello. Am I audible?
for a few seconds and then I came back. So I don't hear what you said. Can you just repeat this question again?
Your audio is not clear to me. You're not clearly audible.
Can you repeat this question? Hello.
Hello. Yeah, audible. Better now. It's better now.
Sorry, I'm having problems today with my laptop. Can you repeat this question, please? Because
Yeah.
I disconnected.
Yeah, sure. Because in this question we have given the equation of a curve, and we have to find out the tangent line to that curve at the point that is given to us. Okay, so we know that the function, if we differentiate that function, we will be getting dy over dx, and the dy over dx is equals to the slope. We discussed in the previous session that if we differentiate the function, we get the slope of that function, or is it clear to you? If we differentiate that function, we'll be getting the slope, and we already know the point. So that's what we need to get the equation of a line. So
Yes.
to get the equation of a line, we need a slope and we need points. Points are already given to us. And to get the slope, we will be differentiating the curve and putting those points into the differentiate formula, and we'll getting the slope of that line at that point. So let's do it.
Okay.
Okay, let's differentiate this function dy over dx, which is equals to the slope. When we differentiate the function, we get the slope. So the formula will be, again, it's f of x and it is g of x, right? So we write which function we write as it is.
Doesn't matter as long as it's one of them. No, the bottom. I mean the bottom.
No, the bottom.
Squared.
Okay, 1 plus x squared as it is, and then we'll be taking the derivative of f of x, so it will be
Ex.
okay, minus sign of the formula, and then ex as it is. Yeah, ex and then just 2x. 2x, okay. And then in the bottom it will be 1 plus x square whole square, right?
Yes.
So m dy by dx equals to ex plus x square ex minus 2x ex. Is it clear? I just multiplied the expressions, and then in the bottom we have 1 plus x square whole square. So we have given the point, we have to find the slope at that point only. So the point is given to us half or 1 comma half e.
So now we have to simplify it further, right?
Sorry?
We have to simplify further.
Yes, 1 minute.
Okay.
It was only ex, right? One minute. Let me check the question again. M equals to dy by dx, and we have to find the slope at only that point. So x equals to 1 and y equals to half e. We will be putting, instead of x, we'll be putting 1. So e raised to the power 1 plus 1 whole square e1 minus 2x is 1 e raised to the power 1 divided by 1 plus 1 square whole square. Is it clear? Hello?
Yeah, it's clear.
Okay. So e raised to the power 1 plus e raised to the power 1 minus 2e raised to the power 1. So I can just write e, right? Instead of e raised to the power 1.
Yeah. So it's become 2e minus 2e, so nothing, 0.
So it will be 0. And in the bottom it is 1 plus, it's 2, it's 4, because 1 plus 1 is 4, 2 and 2 whole square is 4. So just let me write 4 here. So the slope is 0. One point to be noticed here, that when the slope is 0, the line is horizontal. And the equation of a line will be, the generalized equation of the line is y equals to mx plus c. And we know that the slope is 0. So y, the line of the equation is y equals to c. Okay, c is the y-intercept, the intercept that when it crosses the y-axis. But we have given here point x comma y, which is 1 comma half e. So to do that, we will be doing, we have to find out actually the c, b intercept, by putting the point into the equation. Is it clear so far?
Yes.
Okay, so y is half e, m is 0, x plus c. So c will be half e. Is it clear?
Can you repeat this part again? I didn't quite understand.
Okay, so so far we got the slope that was 0. So we know that this is a horizontal line tangent to the curve. So we know the equation of a line is y equals to mx plus c. That's the generalized equation of a line. And where m is the slope that we got 0. So the equation of the line will be just y equals to c, right? and C is the y-intercept when it crosses the y-axis. The line that crosses the y-intercept, we have to find out this point y-intercept where x is 0. But we have given x, we have given a point that is x, x is 1, but we have to find the value of y where x is 0. So what we'll be doing, we will be just putting the points that are given to us 1 comma half e into this equation. Okay, so y is half e, m is 0, so which will make x 0 ultimately, and c, we'll be getting the value of c. C value is half e, right?
But we only used one, right?
Yes, and now putting this value into this equation, so y will be half e. That is the equation of a line.
Yeah, because the slope is 0, so there's no slope.
Yeah,
Okay.
yeah, because we used only one value. The other value will be used for x as well, but it makes, but slope 0 makes the x value, you know, whatever we use doesn't make sense. So it was 0 here. So c equals to half e. That was the only value that was used. Is it clear?
Yes, clear.
Okay. I think we have done the similar question before as well, you know, where we have given
like
the
2 days ago.
Yeah. So the question can be asked in any way, that you are given the curve equation and you have given the point and you have to find out its, you have to find the line that is tangent to the curve. So this question will be asked to you. Now back to the book. This is the summary of the differentiation formulas that we have studied so far. Here is the constant derivative will be 0, power rule, exponential rule, multiplication rule, addition rule, subtraction, multiplication, and division rule. All the rules that we have studied so far, all are covered here. And this is exercise number 3.2. If you want to, you know, exercise more question, then I would suggest you to 3-26. These questions to get a practice of product rule and the division rule. You can also do the other questions as well if you have time, but I will suggest you to do the questions 3-26.
36 or 26?
3-26. The questions from 3 to 26.
Okay.
Now we have now we have to find the derivatives of trigonometric functions. The trigonometric functions are sine, cosine, sec, cos, cosec, tangent, cot. So all are the trigonometric functions. So if we have given you know, the trigonometric functions along with the exponential function, so how we will be find the differentiate. So the first trigonometric function is sine x. So when we differentiate sine x, its derivative will be cos x. Whenever we differentiate sine x, its derivative will be cos x. So let's do question number example number 1, where we have to differentiate y equals to x square sine x.
You said the derivative of cosine is what?
Sorry?
You were saying something about the derivative of cosine, I think, or sine.
Sine x. The derivative of sine x is cosine x. I mean the cos x.
Okay.
Sine x derivative is cos x. And now we are going to differentiate y equals to x square sine x. Can you tell me these two functions, which formula we'll be using?
Multiplication formula.
Which formula?
The multiplication one.
Yes, the product rule.
Yeah, product rule, yes.
Okay, and now we know the derivative of sine x, we know the derivative of x square, and we know the product rule. So we are enough confident to get the derivative of y function. So dy over dx, we can write f dash of x, right?
Yeah, because derivative.
Yeah, and dash represent the first derivative. And if there's a second derivative, double derivative, then there will be double dash here. So dy over dx equals to the formula for multiplication is?
F. It's going to be fx.
This is fx, and this is
Yeah,
gx.
and then gx, and the one we derive, and then the other one we leave as it is, and then we switch.
Okay, so x square as it is, and we have to take the derivative of sine x. We just know that the derivative of sine x is, yeah, cos x.
Okay, sine x cos x.
And then there's a plus sign of the formula.
Yeah, plus 2x.
Okay.
Plus sine x.
Okay, sine x.
Yes.
So will be x square cos x plus 2x sine x. Let's check it in the book.
Fine answer. No need to go further.
Yes, they have. They haven't simplified it. This is the answer in the book. Even if we can't simplify it, we just can take the x common and then write the function like this. Further, we can't simplify it. So this is also acceptable. This is also acceptable, but whichever way you do. So is it clear?
Yes.
Now let's back to the book. And if we are given the cosine function, okay, the derivative of cos will be minus sine x. The derivative of sine is cos x, and the derivative of cos x is minus sine x. Is it clear? You just need to memorize these things. Derivative of sine x is cos x, and derivative of cos x is minus sine x.
It's minus sine. Okay.
Yes. Okay, let's do this question. No, this is just identity. And the derivative of tan x is sec square x. This is a list of the derivative of trigonometry functions. So let's just go through it. The derivative of sine x, the derivative of sine x is cos x, and the derivative of cos x is minus sine x, right?
Yeah.
The derivative of tan x is sec square x, and the derivative of cosec x is minus cosec x into cot x, and the derivative of sec x is sec x into tan x. The derivative of cot x is minus cosec square. These are the 6 identities that you have to just memorize it. That what is the derivative of cot x, what is the derivative of tan x, cos x, sin x. So let's do the question number, example 2. It says differentiate this function. It has sec x, tan x as well. Completely trigonometric function. For what value of x does the graph of f have a horizontal tangent? So we know that horizontal tangent means the slope will be 0.
Yes.
Right? If we differentiate this function, the function f of x, then we will be getting the slope. And if we, equate that function to the 0, we will be getting some sort of x values. At those values, the graph will be horizontal tangent to the f function. This is the question that's asking to us. Okay, let's do this question. Sec x over 1 plus tan x. And we have to find out the x values for which the tangent, for which the graph has a horizontal tangent. And horizontal tangent means we know that the slope will be 0. So let's differentiate this function. It will be f dash of x equals to, again, u over v. I mean, the f of x over g of x formula will be used. Right?
Yeah.
Okay. So 1 plus tan x And the derivative of sec x is, let's
I
get
don't know.
yeah, let's get back to the book for this. The derivative of sec x is sec x into tan x. Sec x into tan x, and there's a minus sign of the formula. Sec x will be as it is, and we will be taking the derivative of 1 plus tan x. The derivative of 1 is 0. Now we have to find the derivative of tan x. Let's get back to the book. The derivative of tan x is sec square x, right?
Yes.
Okay. And we have 1 plus tan x whole square in the denominator. So f dash of x is equals to, if we multiply it, it will be sec x multiplied with sec x into tan x plus sign tan x with the whole function. It will be sec x and tan square x. Is it clear?
Sec and tan. Is it? No, I'm confused. Like, sec and tan, is it considered as 1 or 2?
It's considered as one function because both are multiplied. If they are both added, then we can say that there are two functions. So we have to multiply with each. There's only there's a multiplication sign, so we have to take it only one. Is it clear?
Okay. Yeah.
So 1 multiplied with sec x tan x plus sign tan x with the sec x into tan x. So it will be sec x and tan square x. Is it clear?
You multiply tan by tan.
Yeah, 10 with 10 because 10 with
And
10
sec, we
with
leave
10
it
will,
as it is.
yeah. So it will be sec x into tan square x minus another formula. Sec x with sec square x will be cube x, right? Because base same, power will be added, right? So 2 plus 1 is 3. Same goes with this function as well. Tan x with tan x, so base same, power will be added, so it will be tan square x. And then we have 1 plus tan x whole square. Is there anything common that we can take from the numerator? Yes. It is sec x that we can take common. And then we have left tan x plus tan square x minus sec square x divided by 1 plus tan x whole square. Okay, then there will be an identity use. Yes, do you have any question?
No, never mind. Go ahead.
Okay, there are identities that I think that you know it, but let me just write it down. Sin square x plus cos square x is 1. Do you know these identities?
No, I don't.
Okay, and there's another identity. It is sec square x minus tan square x equals to 1. These two identities that you have to remember, that whenever there's a function, whenever there is an expression in the function sin square x plus cos square x, so you can write 1 instead of this whole identity. And in the function, we can see that we have tan square x, we have sec square x, but we need minus sign with the tan square x, not the sec square x, to get to. We are just simplifying our function here, so we can put this identity here. So we need a minus sign in between. How will we be doing it? Sec x tan x will be as it is. If we take the minus sign common, okay, so it will be minus tan square x plus sec square x. We can write it like this.
Yeah.
Okay, then it will be 1 plus 10x, and we can write sec square x minus 10 is 10x square, 10 square x equals to 1 to simplify our function. So it will be sec x 10x minus 1 over 1 plus 10x whole square. Okay, let me just check the fun book that. Yes, we have got the correct answer. Now we have to find out. We know that the graph has a horizontal tangent. So whatever the slope that we have got we will be equating it to equals to 0. So equating it with 0, sec x 10x minus 1. Is it clear so far?
It's a bit confusing, this one, second and this. I have to practice more.
This part?
I understood it now, but then I'm afraid I do some
Okay,
mistakes
actually
because
there
it's
are,
confusing.
it's lengthy question. So once you do it on the paper, you will, understand what we have done in the session.
Okay.
So we can equate it, sec x 10x minus 1 equals to 0. And sec x will be equals to 0 and 10x minus 1 will be equals to 0. Is it clear?
Yeah.
Okay. So if we, do you have a calculator with you?
Yeah, these are identity also?
Yes. If can we do sec inverse of 0? And we have 10x equals to 1. So it will be x equals to 10x 1, and then x other value is sec x 0.
Okay. These are identities I have to memorize, right?
Yeah, these are not the identities. When you multiply it, it will be 0. Now you are left with only sec x 10x minus 1 equals to 0. Right? You just equate the 0 with each because there are two functions. So you just equate the 0 with each. So sec x equals to 0, 10x minus 1 equals to 0. Because we have to find out the x values. Now 10x minus 1 equals to 0. We can take the one that side. So it will be 10x equals to 1. And if you have calculator, you can put the 10 inverse of 1. Can you take that 10 inverse of 1?
I'm not sure.
Which calculator you are using? Scientific calculator?
Yeah, I can see a scientific calculator.
Okay, can you see the option 10 inverse x in the calculator?
Yes.
Write 10 inverse of 1.
45.
45. So 45 degree, or in the radian it will be pi by 4. And there isn't any solution for sec inverse x. I will discuss it with you tomorrow about this. Why we can't solve for sec inverse x 0. But today we are going to discuss this. There is a solution that x is equal to 45 degree or pi by 4, there's one solution that at this point, our tangent line will be horizontal to the curve that is f of x. Is it clear? I'll leave this point for now.
It's clear.
Hello.
Hello.
Hello. Is it clear? Is this question clear? Except this part.
Yeah,
Everything.
this part is
Okay.
clear.
Okay. So let's end it here. And tomorrow, the same time, or because tomorrow is Tuesday, so I want to ask you schedule which time we should do tomorrow.
I finish at 5:30.
Mm-hmm.
My time.
Mm-hmm.
No, not 5:35 actually. Tomorrow I finish at 5. And then after 5, can you do after 5?
After 5, it will be 6 here. After 5 will be
Like at 5 is okay. Like I finish 4:50. So if we can start at like 5 my time, or I don't have any break earlier.
Okay, I just confirm you in the night because I have to see that I have a class at 6 or not.
Okay, sure thing.
Okay.
Okay.
Bye.
Thank you.
Thank you.